Nowadays, many housewives and food vendors face challenges in properly managing their waste cooking oil. When this oil is poured directly into the sink or drain, it can cause water pollution, pipe blockage, and produce greenhouse gases as it composts in landfills. This problem may seem small, but it actually has a big impact on the environment. Secondly, commercial printing inks that we use every day also have their own issues. Most inks still contains heavy metal pigments such as carbon black and lead, which can release toxic substance that affect the human nervous and respiratory system. At the same time, maybe even cause the cancer. Even worse, most of these inks petroleum-based, which means they are non-renewable and pollute the air due to the release of VOC and non-biodegradable waste.
For your information, most printers are made from petroleum-based material that release harmful gas called volatile organic compound (VOC). This substance can harm our health and the environment. So, in this project, we want to create an eco-friendly black ink using waste cooking oil as a binder and vegetable waste as the natural pigment. This helps reduce waste and promote sustainability.
Our first objective is to produce eco-friendly black printer ink for paper by using waste cooking oil as a binder and vegetable waste as a natural pigment. Second objective is to study the effect of waste cooking oil composition on the physico-chemical properties of the formulated black printer ink. Lastly, is to analyze the heavy metal content in the developed eco-friendly ink.
For the methodology, first we collect waste cooking oil and vegetable waste like mustard leaf. The vegetable waste will dry in the oven until fully dry. Then ground into fine powder and burn in a universal furnace to get the ash pigment. Next, the waste cooking oil was filtered to remove impurities. Then, lecithin was mixed with the filter oil to make the binder, and we used a homogenizer to ensure the mixture was well blended. For the ink base, gum arabic was dissolved in distilled water. The pigment ash was mixed with ethanol and filtered to remove dust. Then, add into the gum arabic mixture. We stir it for a few minutes and homogenize for 5 minutes. Finally, the binder was slowly added into the ink base while stirred. After resting for a few minutes, we add rosemary extract, glycerol, and citric acid to improve stability and viscosity.
Alright, so for the analysis, we run 5 types of analysis for this product. The first analysis is heavy metal analysis, which is we are using XRS spectroscopy. Okay, based on the result that shown in the table, heavy metals such as lead, cadmium, mercury, and arsenic were not detected in the eco-black ink printer sample. It showed that ink is free from harmful heavy metal that can cause organ damage and environmental impact. As we know, according to Nancana, as we know, heavy metal are toxic substances that can accumulate in the human body and ecosystem, causing long-term health effects. And according to Sanchez, the absence of this element prove that eco-black ink is safe to use and environmentally friendly. For the second analysis is pH analysis, which is we are using a pH meter to run this analysis. For the pH analysis, you can see the result right here. In this study, the pH of the eco inks was between 3.62 and 5.78, which is show it is slightly acidic. This is because the ink was made using vegetable waste, which contain natural organic acid. Similar result we found by Zeng et al. 2022 and Nguyen et al. 2023, where bio-based inks also had pH value between 3.5 and 6.0. The control inks, however, had a pH of 8.13, showing alkaline properties that are common in commercial ink made with synthetic stabilizer and surfactant. Among all samples, formulation 3 with a pH 5.78 was closest to the control. This means it is more stable and less likely to cause corrosion in printing spots, similar to what was reported by Rahman et al. 2021.
The third analysis conducted was color analysis using low ribbon tintometer. This is the color analysis result. The commercial black ink shows a bit more yellow, which is 12.67, red is 0.33, and blue is 13.67. According to Apetal and Kotari, commercial black inks usually have a slightly warm tone to enhance print contrast. For our eco ink, especially formulation 3, the values of red 0.50, yellow 14.80, and blue is 15.47. These balanced values create the neutral black color that looks very close to the commercial ink. So our eco ink not only use waste materials but also matches the color quality of commercial ink.
The next analysis we conducted was the viscosity analysis by using viscometer. For viscosity analysis, based on the result, viscosity value was between 22.84 and 45.87 cp. Formulation 3 is 22.84 cp was in the ideal range, 20 under 25 cp for small inkjet printing. recorded by Z. High viscosity in other samples happen because of more vegetable waste, which includes solid content. Equine were generally thicker due to WCO, but formulation 3 gives the best flow and clean stability according by acid printing ink.
For the particle size analysis, we send the ash sample to UTHM to determine the particle distribution. This is the result of our pigment ash. It shows a mix of fine and coarse particles with an average size around 192 micrometers. The span value of 2.5 means the particles are not completely uniform. These findings reported by Ali, where particles non-uniformity is often caused by incomplete milling. A high specific surface area of 80 to 81 square meters per kilogram suggests they are smaller particles that help improve ink dispersion.
So the significance of this study is important because it reduces waste cooking oil to produce eco-friendly inks. This method has reduced water pollution and greenhouse gases emission. It also replaced toxic material with biodegradable and safe alternatives.
In conclusion, formulation 3 gives the best result with ideal viscosity, stable pH, fine particle size, and no heavy metal. It is eco-friendly, safe, and perform almost like commercial ink, showing that waste can actually be turned into something useful and sustainable.